Hi, grade 6. Our new science lesson for this week is about electrons and chemical bonding. And throughout this lesson, we are going to learn how do atoms join together, and we are going to see what happens to atoms during chemical changes. First of all, let us start our lesson by learning how do atoms join together. Atoms of a limited number of elements join together in different ways to form the many substances around you. Some substances, such as water, are made up of only few atoms. Other substances, such as DNA, can contain billions of atoms. A huge variety of substances are possible because atoms join together by forming chemical bonds. What are chemical bonds? A chemical bond is an interaction that holds atoms or ions together. So, a group of atoms that are held together by chemical bonds is called a molecule. So, if we look at the picture below, it shows a water molecule. All water molecules are the same. They are made up of two hydrogen atoms bonded to one oxygen atom. So, if we look closely at the water molecule, we can see that it contains two blue spheres and one red sphere. Each blue sphere represents a hydrogen atom and the red sphere represents an oxygen atom. So a water molecule is made up of two hydrogen atoms bonded to one oxygen atom. Now, let us see what happens to atoms during chemical changes. We already know that chemical changes change the identity of substances. But a chemical change does not create or destroy atoms. Instead, the atoms are rearranged to make new substances with different properties. In order for atoms to be rearranged, chemical bonds have to be formed or broken. The models below show how hydrogen gas and chlorine gas undergo a chemical change to make a hydrogen chloride molecule. So, in this picture, we have to know that each blue sphere represents a hydrogen atom and each green sphere represents a chlorine atom. So, in a hydrogen molecule, two hydrogen atoms are connected by a bond. In a chlorine molecule, two chlorine atoms are connected by a bond. A hydrogen chloride molecule forms when a bond is made between a hydrogen atom and a chlorine atom. So this is how atoms are rearranged to make new substances with different properties. How can you tell that atoms are not created or destroyed by the chemical change? We have to know that there are the same number and type of atoms on each side of the equation, so atoms could not have been created or destroyed. Now, let's see what do different atom models show. Because atoms are too small to observe directly, scientists often use models of the atom to show how atoms behave. They use different models depending on what they need to study. For example, the way a model shows electrons is important because electrons are involved in chemical bonding. We have to know that we have three different models used to represent atoms. First model is called the electron cloud model, and this model shows how electrons are found in a region around the nucleus of an atom. It helps show the general locations of the different parts of the atom, but it does not show the number of electrons. This model is shown in picture number 1. Second model is called the Bohr model. This model shows the number of electrons in an atom. The electrons are shown as dots placed in rings around the nucleus. This model is shown in picture number 2. The third model is the space-filling model of a molecule. It shows that atoms are represented as solid spheres. The spheres do not show the parts that make up the atoms, but this model clearly shows how atoms are connected to each other. This model is shown in picture number 3. and this model uses spheres to show the 3D arrangement of atoms. Now let's move to the valence electrons. What are valence electrons? We have seen before that Bohr models show electrons in energy levels. Each energy level can hold a specific number of electrons. The first energy level can hold up to 2 electrons and is filled first. The second energy level can hold up to 8 electrons. Now, many atoms have additional energy levels, but electrons are usually not added to higher energy levels until the lower ones are filled. The energy level furthest from the nucleus is called the outermost energy level, and electrons found in the outermost energy level of an atom are called valence electrons. So let's look at this picture. This is a Bohr model of an oxygen atom. The first energy level can hold up to 2 electrons. This level is filled first. The second energy level can hold up to 8 electrons. Larger atoms have more energy levels, which can hold more electrons. Now let's take a look at this example. A fluorine atom has 9 electrons. Let's draw a model to determine how many valence electrons the atom has. So, already know that the first energy level can hold up to 2 electrons, so we should add 2 electrons to the first energy level. And we have 7 electrons that still need to be added. So in step 2, it shows that we already added the 2 electrons on the first energy level. We should add the remaining electrons to the second energy level, so we should add 7 electrons to the second energy level. But we already know that electrons found in the outermost energy level of an atom are called valence electrons. So how many valence electrons does fluorine have? It has 7 valence electrons. Now let's see how does the periodic table show the number of valence electrons. You can determine the number of valence electrons by using the periodic table. Let's see how. The atomic number of an element listed in each square of the periodic table is the number of protons in each atom of that element. In neutral atoms, the number of protons equals the number of electrons. So, the total number of electrons in an atom is equal to the atomic number. Now, we have to know that elements in the same group or vertical column have the same number of valence electrons. And we can use the group number to find the number of valence electrons in groups 1, 2, and from group 13 till group 18. Let's look at this periodic table. Group 1 atoms have 1 valence electron, so all atoms of group 1 have 1 valence electron. Group 2 atoms have 2 valence electrons, so all the atoms of group 2 have 2 valence electrons. Now, atoms of elements in group 13 till group 18 have the same number of valence electrons as the last digit in their group number. For example, all atoms of the elements in group 16 have 6 valence electrons. Exception, helium atoms have 2 valence electrons. Now, how many valence electrons do nitrogen and phosphorus have? Let's find nitrogen in the periodic table. Nitrogen is in group 15, so it should have 5 valence electrons. Phosphorus is in group 15 also, so it has 5 valence electrons. Finally, let's see why do atoms form bonds. An atom tends to form bonds if its outermost energy level is not full. So atoms that have fewer than 8 valence electrons, except for helium, do not have a full outermost energy level. These atoms gain, lose, or share valence electrons to form bonds, and forming bonds allows atoms to fill their outermost energy level. For example, a chlorine atom has 7 valence electrons. It needs one more electron to have a full outermost energy level. So a chlorine atom can gain one electron from a sodium atom, and when this happens, the chlorine atom becomes a negative ion. An ion, by definition, is a charged particle that forms when an atom loses or gains an electron. So the sodium atom that loses the electron becomes a positive ion, but the chlorine atom that gains one electron becomes a negative ion. That's it for today, grade 6. Thank you for watching.